Okay, Assalamualaikum warahmatullahi wabarakatuh. Previously we have learned that this is the mole balance for batch reactor, right? Batch reactor. Okay, so now we are going to learn about ideal batch reactor, in which we will learn that um, it can be expressed in term of the conversion or in term of the concentration. This term can be expressed in term of these two, okay, concentration and also conversion. From this equation we can put negative sign on both sides, where if we put negative sign on the left hand side, we also need to put the negative sign on the right hand side, so that we are not it to indicate that we are not disturbing the initial equation. Okay, we just add this negative sign on both sides. So from this equation we can get below equation. But how to get this? Okay, we know that if we have initial concentration of Na naught, and then we have if you want to relate it with the conversion, so we if Na naught means the conversion is equal to 1, right? If at time x, so we have x a as the conversion. Okay, so how to write this? We can do like this: the initial minus with the initial mole times with xa at certain time, and then we will get the number of mole at Na. Okay, we can factorize this. We put Na naught outside, then 1 minus xa, and then become equals Na. So from this, okay, we can relate this term Na, okay, here Na, with this one. We can replace Na with this one. Okay, that's why we have derived here just now. Okay, and then we need to express this in term of dxa. So since here for this term, the only part that we have xa is this term only, right? So we can ignore 1 here, because anything that is being differentiate uh, with respect to xa, for example dxa dt, we have 1 here, so we cannot differentiate it because we don't have xa term here, so it will become 0. That's why we will have this term only after we have cancel or omit uh, um, the first term, which is number 1. To recall your knowledge on differentiation, okay, if you are differentiate something, that means we need to have, if you are differentiating x, we need to have x term. Differentiating y, we need to have y term. So if there is no x term here, for instance 1, we don't have x a term here, so we can make it as 0. Okay, please go and check your differentiation knowledge once again, so you will understand how to get this term here. Bear in mind we just derived the term for dna over dt here. So here, okay, dna over dt, so we need to express all of this term. Okay, we go to this part, okay, where we rewrite the equation negative RAV and then replace negative NA with what we have here, okay? And then why from negative it become positive? Because here we have negative sign as well. So negative times negative, it will become positive here, okay? Positive. Then we can solve this whole equation, okay? We are going to solve and make it in terms of t. So how to do it? We rearrange this equation like we have done previously, okay? What we need to do is we bring dt to the left hand side, so we will have differentiating 1 dt, since it, sorry, integrating, not differentiating, integrating dt, because this is integration, that means we can differentiate number 1, this one, or constant. So we can put t t equals 0, and then t equals 1, t equals t equals, then we have n a naught here, differentiate 1 over negative RAV, we bring this to the right hand side, and then we can put like this, dxa. So we are going to differentiating in terms of x, so we can put x equals 0, x equals xa here. Okay, so when we integrate this, what we will get is t, like we have done previously. You can check again the slide. Okay, we got t, and then it is equal to this side. That's why we get this term here. Okay, once we get this equation, we can express in terms of the graph. Okay, so how, what does each of the term here uh, give us, tell us? Okay, so what we have here is we can bring an a to this side, so it will become t over n a naught, and then it is, we can omit this term. So we have done that, we are going to um, express this whole thing as the area under the curve. Okay, because we know that by integrating something, we are going to get area under the curve, and then from this we can see the limit from 0 to xa, so that's why we have 0 to xa here, and then the whole thing will be the area under the curve. And then since this is um, the term that we have here on the right hand side, so we have bring an a naught to the left hand side, so this will be equal to the whole integral part here. That's why we have area under the curve equals t over n a naught as well. Last part for ideal batch reactor mole valence equations, we are going to express it in terms of the concentration. Okay, so if, previous slide we have this equation. To make it as concentration, what we need to do is we can bring v here, so it will become in a naught over v. This is the concentration equation, right? So we can replace with this ca naught. Okay, and then the other term will remain the same here, remain the same. Okay, and the same like previous slide, we can bring this ca naught, okay, to the left hand side. Okay, and then this whole term is the area under the curve. That's why we get this curve here, and then t over ca naught is the area as well, so we have t over ca naught equals the integral part. Bear in mind, for this graph, the limit is still in terms of the conversion, which is from 0 to xa. So if you want to express in terms of ca to ca naught, okay, what we need to do here is we can relate, we can use this formula that we have done previously, ca naught minus ca xa equals ca, right? Sorry, ca naught here equals ca. We rearrange this equation, we will get ca naught xa, bring to this side, so we'll get ca naught minus ca. Okay, we know that ca naught xa is the same like here. Okay, we have ca naught and dxa, sorry. So if we are integrating in terms of ca here, that means this term differentiating in terms of ca will omit this term. Okay, so it will give us negative ca here, right? So it will become negative tca. However, we need to integrate this because we want to get the limit from a naught to a, right? As we have discussed previously, we want to express it in terms of integral so that we can get the area under the curve. So what we need to do now is we are going to integrate this. So we have here with the limit of ca naught, CA, then minus 2 DCA, and then previously we have this term, right, negative RA here, so we bring negative RA as well. Okay, but here actually we can make it as positive when we reverse the limit, so actually it will become CA naught here and CA at the bottom. Okay, so we have omitted this negative sign, so here as well actually CA naught, okay, initial, right, so the value is lesser than CA. uh, so lesser than CA, so you will become CA naught here, this is CA. Okay, so the same like this one, so we have area as T because we don't have any other thing to bring to the left hand side, so we have just left with this integral form. Okay, that's why we have area equals T, and then the whole thing is the integration of this, so it will become area under